All right, so we've covered most of the theoretical journey at this point. Now we can talk about the genesis block of it, which marks the starting point for your blockchain or ecosystem. So a genesis block is typically the first block that you can imagine in any blockchain solution or any blockchain protocol. You can imagine it this way. Let's say you're trying to create a Web2 application. Now, to start a Web2 application, or let's say you're trying to create a server, right? You're writing a server application in Node.js, in Python, in Golang, or in any other backend language in Java, right? It typically is going to use a database, right? You're going to expose some API for the idea that you're working on. Now, to interact with the database, you need these tables pre-created, right? You need the database pre-created. You need user credentials pre-created, and you need tables pre-created. And in some cases, you also need master datasets pre-created, right? So what engineers do, they write migration files where these migrations have the queries that helps you create the first stage of your database, where it is going to create the tables, it is going to create additional uses for you, it is going to store metadata that is required by your application. Similarly, you can imagine this in Genesis block as well. This is going to set the base for your blockchain. So this means you can allow participants that are going to be participating in your blockchain, or the stakeholders that are going to be participating in your blockchain, be worthy of some rewards. So what people do when they start their blockchains, or with Genesis block power, they pre-mine some assets. So let's say you try to create 1 million of stable coins, or 1 million of supply with your blockchain for the native token that you're using. Okay, what people do, they usually pre-mine these tokens or coins onto sets of addresses. That gives you capability to have some control of your coins that you've created, and then you can later redeem these rewards once your stable coin has gained the popularity or has some value that you can maybe exchange this onto. So Genesis block helps you settle that part. And if you talk about typical solutions or customized blockchains, then these Genesis blocks can help you decide which validators are going to be, are going to hold special permissions. I'm talking about a very vague example here, that these could be admins, or these validators could allow special signing permissions that if they, or they could hold the veto power in some decision making. So those kind of capability you can introduce in your Genesis block. Now, these states or these permissions or these information encoded in Genesis block does not mean that you cannot change these parts. In a lot of blockchain solutions, you can these parts, or you can change these permissions based on the consensus you're using, or depending upon the approvals that you get on that particular request or proposal. Okay, and if I talk about Bitcoin, then Bitcoin again had the similar principle, where the data that was encoded was a headline from a newspaper, right, which was mocking one particular bank, and that is what was encoded in the first Genesis block of Bitcoin in 2009. So what Satoshi Nakamoto did, that he pre-mined 50 Bitcoins to his address, right? So a lot of people also say that, let's say if Satoshi Nakamoto wants to prove his identity, the one way to prove his identity is to prove that he holds a Genesis block address, right? Those Bitcoins still haven't been used at any point. Those 50 Bitcoins are still there, and they haven't been redeemed at any point. So if anyone who could prove that he holds the private key which holds that address, and that proves his identity, right? So I think at this point we can take a break, and once we come back, we can talk about what are the details that are stored inside Genesis block. We can take an example of one particular Genesis block. Maybe we can explore raw JSON of the Genesis block for Bitcoin, and we can see what are the details that are stored inside the Genesis block, and then we'll talk about more bunch of technical details once you guys come back. Usually when you start private consortium, it holds global details like permissioning and some of the global state that you're trying to set in your smart contract. That is one. There could be one or few blockchains out there that use this principle, but in public blockchains where there are no transactions capability. For example, if I talk about Bitcoin, it usually holds a message that you can encrypt, and then it can hold pre-mined addresses that you can again put down to allow some initial funds to your stakeholders, or to your multiple wallets that you want to store funds into, and gives you capability to redeem those funds or to manipulate those funds in any manner that you want to. Let's take an example of a Genesis block, and let's see what it exactly is that it holds. Right, so this is one of the typical block explorer that I found, and on the other hand, I have this tab which allows me to get data in JSON, and we'll see how it looks in JSON as well, just to understand the things in detail. So it helps us understand that this is block 0. It also tells us about the message that it holds, right? It is called coin-based message that you can encrypt with your private key that you want to sign this transaction with. Okay, let's copy this hash here. Let's try to put it down in this tab and see what we can get in JSON detail. All right, so this is the typical structure of a block, and this structure here helps us understand how you can understand the information that is residing inside a block, and how you can basically drill down on the details that it holds, right? So the height here specifies the block number. Okay, and then every block has a unique hash, which is the hash of the contents that a block has, and it has a identifier to the previous block. In our case, it is a null address or a null hash, you can imagine. Okay, and then it has a pointer to the next block. Now you'll notice that the next block section has an array here, which is a capability which allows you to create multiple forks in the block. So in a scenario where a fork is created, you'll see more number of blocks, or maybe 2 blocks of hash here, where there are where these forks are going in parallel. Okay, and then it has the fee that was generated to mine this block. Nonce is basically the difficulty that this block that this block was mined with. Now nonce usually could depend, or could vary depending on the protocol or consensus model you're choosing, right? In POW that Bitcoin incorporates, it gives you the capability to solve, or it asks you to solve a mathematical problem, basically to create a hash out of a number, and the hash that it wants you to create is actually a very complex problem, because to solve that part, you'll have to do random numbers, or you can say sequential of numbers, to generate that, or to solve that particular mathematical problem, which is called proof of work, or you can say POW. So this nonce here represents the POW part. Okay, any miner or any node which is going to accept this block is going to verify this by putting down this nonce into the same mathematical problem, and see that the difficulty that this block was set with is matching this nonce. Okay, then it has a number of transactions in this block. Okay, so it has only one transaction at 0th address, at 0th index, and there is weight, which we're not going to talk about at this point. Block index usually represents the height of the block. So what we've seen, it typically represents the data in a visual format, this slide here. So we've seen a Genesis block where every block has an identifier, okay, which is hash of this block, and a previous hash which indicates a previous block, or the parent block for this particular block, and it also has an identifier which marks it to the next block of the blockchain, right, that we saw. This way you can see how it is creating the chain of blocks, right? Similar to how you guys must be programming linked lists, right? A linked list is similar. I'm not saying that that is how exactly it is implemented, but you can imagine the concept of it in a practical way, that it is similar to how we implement linked lists, where there are pointers pointing the forward elements, and in some cases there are doubly linked lists. You can also backtrack to root node as well.